Hi there, I'm Trace, and we're going to do some data analysis today from some data that I acquired a while back. Let's get started. Let's see where I can put this off. All right, so this is some data that I acquired a while back, and you can see the form here, the profile. I actually ran the data across the magnet once, and then I doubled back and acquired some more. I'll show you the reasons why I did that in a little bit. So let's take a look at the video. So when I'm running it, I'm getting one profile, like a sine wave, when it passes across the magnet. And then when I double back, I'm getting the second sine wave right there. All right, that's where we get this two profiles here. So if we look at the data here, we're actually only gonna use two columns, the force and the angle, and the time. You see the time here? When we use the data, these 2 points correlate with one another in time, but we're not going to use the time. We're just going to use this. So as long as these are paired together, it's going to be good enough for what we're doing. So let's take a look here. So I was able to import this into a spreadsheet within this math emulator. Let's take a look here. So that will be this data in these columns right here. So how many points do we have? Close to 1,100 data points. Now, that's going to be plenty of information for us to do some data analysis. Now, let's take a look here. From this data, I was able to import that into a graph. And this is our scatter plot right here with that data. So if we zoom in, you can see the data points here. So let's go back. So the resolution of the arc angle sensor is, I have it set for 1/4 degree. I can't get any finer detail, so you can see a bunch of data points within each 1/4 degree. So we got these data points here. Now, for us to do some data analysis, we need to do some regressions to construct a function, if you will, that fits this data. So we're gonna construct a line that's gonna go across here, down through here, and across here. And it's pretty cumbersome and time consuming to do this. But it's necessary to get an understanding of what's going on. All right. So where do we start? So we got the data points plotted in a scatter plot on the graph. Now it's a matter of doing some regressions. I'm not able to, this math emulator isn't able to do a regression to construct a line that closely fits the data. So we have to slowly build it up, doing multiple regressions. So I take a section of data points here and I do a regression. So let's go over a couple segments so you get an understanding of how I'm constructing this function. Let's go to the first segment. Oh, let's back it up. So function 1. So this is a regression that somewhat fits the data within this region right here. So let's take a closer look at this. The function view, zoom, box. All right, so it's right in here. So I'm using this data right here to construct a regression line right in here. So if we take a look at this, is it this spreadsheet? All right. So right here, our starting point is at 0.0087. And we got about 260 data points within this region, and we stop at 0.05. So 0.05. That's roughly right in this area here. So we're using the data from here to here to construct this line. Escape. So this is function 1. So we got 740.96 blah 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 all the way over here. So that would correlate to this this regression function. Is it this one? No. Right here. So this will be a B and C. So this is the regression for that data. Okay, so let's take a look at the next segment. Zoom out. Let's go function for the next segment here. All right, so it's the next segment is right in here. Let's get a closer look at this. All right, you can sort of see how this regression sort of follows the data right in here. That's what we're looking for. We have this other line right in here. So where these intersect, I take a segment here of this line and then a segment of this line. And then I'll have another regression for right in here. Then I'll take a regression. So I take for my final function, I just take a segment here, add it to this segment here, and then add it to another segment here. All right, so let's take a look at the data points here. So I roughly grab data from this point to right in here, and I use that data. So that would be this section right here, 16861. So if we look at our function here, so that's that segment right here, or that's that data on that spreadsheet correlates with this function right here. So now if we continue, let me zoom out. Now I got the next little segment here, the next segment, and then the next one. It's starting to get busy here, a lot of lines here, but it'll come together in a little bit. I'll show you. So now we have another little point right here. Oops, function. Another little segment. You can sort of see how this is coming together. Another little section. Another little section in here. All right, so if we zoom in, we can sort of see this line right here go to this red line. Red to blue. It's getting really busy here. All right. So I think you get the gist of that. It's pretty busy here. So let's take a look at what I do with all these. So if we go to our function, so there's function 1, function 2, function 3 right in here. So I'm taking little segments of each function and add them all together. So when I turn this on, you can sort of see how it's highlighted right here. The pink, see that? and how it's fitting the data. All right, so let's highlight this a little bit better. Box. So if I turn this off, so now you can see how my final function that I constructed fits the data. Zoom out a little bit. Escape. So you can see how it fits, somewhat fits the data. Now it's not perfect. So I'm not getting the exact regression to fit the data perfectly, but it's close enough to get an idea of what's going on here. Zoom in so you can start taking a look at the fit. So I wasn't able to get any data here. I just didn't have the range on my data acquisition system. But you can sort of see, you know, it's not really a nice clean transition right here. And the fit is, I mean, it's not perfect. It somewhat fits the data right here. So yeah, you can sort of see it should probably be a little bit lower right in here. Not a perfect fit. Zoom out. Zoom out. Let's go box. All right, so there's my final function. Escape. Let's hide this. All right, so now the next step is to do a integral of this function to see where we're at. So what is an integral? It's counting the area underneath the curve, under the function, and above the and below the x-axis. So let's do a quick little regression, or not a regression, but a integral. This function from this point here to here. So that's the area. Let's increase that accuracy to 9 decimal places. So what we're going to do is we're going to add up this space underneath the line here and add it to this guy, that space. So let's grab this, control copy, and add it to another calculator, paste. All right. Now we're going to take another integral. Pick this function from this point here to this point here. Okay, so let's increase the accuracy to 9 decimal places. So we're going to take this, control copy, and add it to the other area. Paste. Now we're going to add that to the area. We're going to add the area underneath this curve and the area underneath this curve. We're going to add both of these and see what the difference is. Okay, so let's do another integral. The integrals are essentially adding up the area underneath the function. From this point to this point. Attributes. Okay. Control, copy. Another thing, notice this negative. So this is a negative area here, negative area here. Right? This is positive. This is a positive area. Let's take note of that. Control B. Let's do, let's get the area underneath this little section right here. Integral function, that point, go to that point. Attributes. Control copy. Plus Control V. Paste. Alrighty. So there's our answer right there. So it's 0.051716. But now if we take a look at this document right here, let's back this up. And if we take an integral of the entire line, let's go from here to here. Now you see this guy right here? Attributes. So 0.05171. If we go back over here, it's the same number. So you get an idea of what's going on right there now, okay? That's what this number is the difference between the areas. All right, there's something else to take note of. Now you see this 0.0517. I want you guys to understand one thing, is that if we take a look at our scatter plot again, we zoom in, you see like I mentioned before, this line doesn't really fit the data perfectly, okay? And there's errors in my function here. It just doesn't fit perfectly. Now, if it did fit perfectly, this number here would actually be 0. There'd be no difference in the area between here. When I add this in this area, and I add it to this space, or this area and this area, there would actually be no difference. So that would be actually 0. It's really important to understand that. I didn't quite understand that at first when I started doing my this design, and it's key because this will always be 0. All right. I think that's going to be enough for today. we'll cover what I end up doing with this function here, this line. I have mathematical models that I could plug this information in to see about a different combination of magnets to see if I could get a motor to run with, and how to manipulate that. We'll cover that in the next video. Until then, peace.